is Make a Geek and I'm Dan. Welcome to the workshop. This is kind of a bit of an update video on the robot arm, but wrapped in a video about making 3D printed things stronger. That's probably a bit of a misnomer really. Reinforcing 3D printed things with steel, with metal. One of the challenges I face when making my robot is that I need precise parts that the 3D printer is capable of making that I lack the otherwise skills, tooling, etc. to make, such as gears and cogs. So this is the inside of one stage of the planetary gearbox that drives the main axis of the robot. In fact, it drives lots of axes of the motors of the robot. I have a few different versions of this. They're all basically the same way. The ethos of the design of this for me was to use these. Let's try not to make it 4 pieces. To use these standard skateboard bearings. These are fairly cheap to come by, as like the core, steel core. And actually, most of them I have these metal standoff pins. So you can see that this is a 3D printed standoff pin, and that is okay. This is actually a carbon fiber reinforced one, I think. But that's sketchy. Most of them are steel ones. This doesn't actually want to come off at the moment because of the fit is that close around the edge. So the core of this gearbox is really steel. Steel ball bearings, steel skateboard bearings, steel pins, and the output plate. Where is the output plate? Oh, it's over there. The output plate is a machined aluminium plate that screws onto these posts. So where I can use metal, I have used metal, but I don't really have a good way to make the precision teeth and like something like this in metal. So these are 3D printed, and the whole idea is to try and get the best capability that I can get from the 3D printer and reinforce it with my limited machining capabilities. But the crux of this, the weakness, the point at which these two things really collide is with this part. This is from each stage. If you want to build up a planetary gearbox that has more torque, you need to add stages together. So the output of one stage has to be condensed down to the sun gear as the input to the next stage. And so all of the torque of this stage and every previous stage is being driven through this bit. And what happened is that this sheared to pieces. So I've done various iterations of this. The first one was just 3D printed, and that did not last very long at all. It just completely sheared off at the layer lines for the printing. This version I basically printed with an 8mm hole through the middle, and I press fit and glued a steel pin through the core, with the hope that that would provide a little bit more resistance to just shearing at that kind of critical point. And this did actually pretty well. This did pretty well until I very stupidly drove the axis into essentially a hard stop. So I really forced the torque through the roof, and this sheared to pieces. But I think that rather than just remaking one of these and hoping for the best, I'm going to upgrade it. And so that's what this video is about. What am I doing next? So this was, let's call this V2, steel pin through the center of a 3D print. We are now gearing up for V3. So from this side looks the same. This is a reprinted one, hole through the middle. But on this side we have recesses. And so what we're going to do is take some steel section that will ultimately press into here. I'm going to precisely drill the locations for the through holes and the center hole, and then I'm going to weld a steel pin into this so that it'll still go through the core, but it'll be welded into this metal plate, and that metal plate will be attached to the screws that go through, and I will weld some wings on this so that I can do the same thing that way. So in theory, the screws that go into the steel pins in the middle of those steel bearings will bring the torque straight into the steel, and the steel will turn, and that will distribute the forces better. Now, it is still entirely possible that this will end up just shattering off of that core, but this is an upgrade. This is probably the only next level of upgrade I can think of before I genuinely have to start figuring out how to make a sun gear in metal, which is not, like, it's not impossible to do. You could make a custom profiled piece and kind of slowly carve away at the teeth and index a turning. It would just take a long time to make something this specific. I can potentially send it out to be manufactured or printed in more strong materials, metal printed, whatever, CNC'd by someone else. But for now, we're going to do this. I'm going to pop this steel on the mill. We're going to measure it out, drill out the pieces, weld it all together, hopefully press fit it. So this is just like a shroud. The only job this has is to try and distribute all of that torque forces as evenly as possible, so that it is able to take what I think I calculated should be around about 50 Newton meters of torque out the other end. Now, this is not actually even, that shouldn't be that much, because this is actually a middle gear, because the actual output, where the last stage worth of torque is going into a aluminium plate which is bolted all across the surface of that last output stage. So that actually is already a steel output plate. That's easy, or I say steel, an aluminium output plate. That's already very good. So this is the last stage before that, where the torque is highest in the smallest area. Let's do it. So, first things first, I'm going to have this in the middle vise. I'll leave that in a little bit around. So here it is precisely a length of just measure that. Alright, so we've done the middle. We just need to come 24 out either way. Bring out. So that is what that looks like. Nice simple machining operation. Let's go to the welding table. That's where it came from. Let me just. Right. Then. Alright. This is the bit where I invariably am going to block the view of the camera, because just the way it tends to go. But in theory, I don't think I should need any filler for this. I think I should just be able to run around, but just in case, sometimes it can be useful to have filler just to start things off. Right, that should do it. Very simple little job. Now, how deep is the penetration of that weld? I suspect so much more strength in whatever that is than the 3D printed part had that it is irrelevant. My main concern is whether I have really going to warp this piece of metal in a way that's difficult to deal with, but I suspect I can come back from that. So next thing to do, add some wings. Alright, back at the mill. I've mounted my cross. Hopefully it's cooling down. And what I probably need to do, so I know that the mill is still on center for this width. So I should be able to come out here, and I know that I'm centered on this axis. So the trick now is to figure out when I'm back on center for this axis. Pretty dead on center. All right, so that is that. Dump it in there. So a little bit more tidy up with the grinder, but hopefully, well, let's test it this way, I suppose. Pretty good. I think that's going to fit. All the holes align, so I just need to grind these flat, press it in the other way around, and then hopefully we have our steel core. Let's go back to the grinding side. I'm gonna sneak some glue under all these surfaces, and in the end, whilst I can, that is one substantively reinforced sun gear. So I'm going to chuck it back in the gearbox, and I guess we'll see how we get on. Yeah, let's do that. Alright, it's tapped back in place. Not all of these screws are going in the way I would like, but I think we're pretty solid. And if I do a short move, I mean, that's something. So let's just give it some welly. Okay. Let's go 3 times that much. So far so good. Let's go even more. It's looking alright. It's looking alright. If I go much more, we're going to start clashing, I think, but let's do this. The weight distribution changes as it goes up, and I don't have anything holding this axis steady at the moment, so it rotates fully in that direction. Cool. That, for now, is in place and stronger. Let's bring you down. Right, so next thing to do is take the small motor off of this gearbox, put the big motor in, mount it on the next axis, and yeah, we'll see how that goes. Alright, so got both motors connected, wired up to reasonable controllers. What I don't have is the top motor is not really bolted. It's kind of wedged on top, so it can't move very much, but there's a little bit of slop here. But nonetheless, I'm keen to have a play, so let's do that. So in theory, I should be able to drive this and this at the moment. What I'm going to do, I think, is well, let's do that and that. So that definitely moved one axis. Did it move the other? Let me... Ah, yes. So I kind of did a... I get a bit nervous about some of the noises. There's a lot of pressure. So that doesn't look like this axis is moving, and actually that's because it's moving at the moment counter. If I wasn't moving it, it would have shifted up more. So let's just try. Right, yeah, so it moved very slowly at the end, but all of the rest of that motion was just rotating the gearbox on the back here because it's not connected to anything. So I think, yeah. Let's get bold, shall we? Let's get bold. Let's go. Okay. Let's do. Okay, so I'm gonna move this one back this way, but I'm gonna raise the main arm up another load. None of these axes are connected to anything yet. Neither is the rotation axis, so it kind of just wants to do its own thing. That was good, but again, there's so much slop in the gearbox that this did kind of very little motion. I'm going to try that again and see whether or not I've taken the slack out. Let's just manually bring you around. It's pretty cool, right? That's pretty cool. I'm going to take it all the way up. Ooh, that's a lot. I'm going to double the drop on the main arm. Well, and this wants to rotate. That's pretty cool. Let's just prove that the main arm does. Ooh, that was a little bit close for comfort. Wow. Two motors moving. I do need to improve the mount for this second axis, and then I need to rerun all the electrics and power to control all the other axes, but we're nearly there. We are nearly there. Well, that was exciting. The two most important axes are now done. That strengthened sun gear seems to have held up so far to, I mean, this whole thing does weigh quite a bit at this point, so the torque required to shift that whole thing out, particularly when this is extended out, is quite high. So pretty happy with how that's performing so far. We'll see how it stands up. And if necessary, I might have to repeat that for other gearboxes. But for now, the power is good. I have all of these other cables that are for this motor and this motor and this motor that all notionally work, but what I need to do is extend them all to run the cables around the robot properly. I've got a bunch of sensor stuff that I need to finish tweaking. So there's a lot more still to do. If you are interested in the progress of that sort of thing, then you should probably subscribe and maybe comment. Make sure that YouTube knows that you want to be brought back when the next video comes out. Failing that, go check out Instagram, because I tend to put more of the interstitial kind of progressy stuff there. For now though, thanks for watching. See you next time.